All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. All right, people. I believe. So, guys, let me know in the chats if I'm perfectly audible, visible to each and every single student. Okay? Let me know in the chats if I'm perfectly audible, visible to each and every single student. And make sure everybody of you smash the like button because liking the session is mandatory. Okay? So I would want you guys to smash it as soon as possible. Okay? Let the people come, let the people join, and we are starting the session accordingly. And this session is extremely important, my dear NEET aspirants. Okay? When it comes to this particular session, this is going to be the ultimate physics replica. I will be showing you the questions. For sure, you can expect similar type of questions in your NEET 2026 examination. Okay, because I have done the analysis in detail, I have done the analysis properly. So that's why on the basis of that analysis, you guys can expect the questions, something of this sort in your NEET 2026 examination. Okay. Yes, yes, yes. Okay. So basically, my dear NEET aspirants, I would want you guys to stay till the end because we will have to finish all the questions today. Okay. Yes. I would want you guys to stay till the end, till the end. Make sure you smash the like button because liking the session is mandatory. Liking the session is mandatory, that is for sure. Okay? Yes, 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 yes. Now, my dear NEET aspirants, I think we must start this particular session. Before that, I would want you guys to join my Telegram channel. That Telegram channel is basically t.me slash Yawar, Y-A-W-A-R, Yawar Manzoor, Manzoor. Okay, so you can basically search this in Google and you will find my Telegram channel. The name of the Telegram channel is Yawar Manzoor Physics. Okay, Yawar Manzoor Physics. So I'll be sharing notes, each and every single update in this Telegram channel only. So make sure everybody of you join this particular channel as soon as possible. Now, guys, let's first move on to the question number 1. This is the first question that we have in the today's session. Please read the question very carefully. Okay? And answer this particular question. These are the options that you have over here. A metallic ring of is uniformly charged as shown in the figure. This is a metallic ring. It is uniformly charged. Okay? AB and CD are the two mutually perpendicular diameters. This is AB, this is AC, and this is BD. And then it says electric field due to arc AB at O. Electric field due to this arc AB. Okay, at O is given as E. Now tell me, my dear NEET aspirants, when it comes to this particular session, when it comes to this particular portion, this is we know chord. Okay. And then it says that what would be the magnitude of the electric field at O due to ABC. So due to this A, B, and C, what is going to be the magnitude of electric field at point O? Guys, understand this very carefully. It says electric field due to AB. It says electric field due to this AB. It is given as E at O. And we know this electric field E is actually a root 2k lambda by R. Why, sir? Because we have studied previously, my dear NEET aspirants, if this is a chord, the electric field due to a chord at its center, it is going to be root 2k lambda by R. This is the electric field due to a chord at its center, that is a root 2k lambda by R. Okay, yes, I can say it something like that. Now, my dear NEET aspirants, when we say ABC, this is a semicircle. So we say electric field due to ABC. ABC is a semicircular wire and electric field due to a semicircular wire. Let's consider it E dash. This would be 2k lambda by R because we have studied this also. electric field due to a semicircular wire is 2k lambda by r. Yes. Now, can I write it like this, my dear NEET aspirants? I would say root 2 into root 2k lambda by r. Yes. Why, sir? Because root 2 into root 2 itself is 2. That's why I can write it root 2 into root 2k lambda by r. Now, this root 2k lambda by r is actually E. So, you can say this E dash. You can say this E dash will be, this is root 2. And instead of this, I can write over here E. So, answer is going to be, that is a root 2 of E in this particular case. That is option second. Is this clear? Is this clear, my dear NEET aspirants? Is this clear? Is this clear? Yes. Now, there is a small thing which I would want you guys to understand over here. Please understand this very carefully. You are having N capacitors. These are joined to form a big capacitor. This is extremely important. I would say very, very important, my dear NEET aspirants. For sure, you can expect the question from this. You have N number of capacitors. These N number of capacitors are joined to form a big capacitor, or in some questions it will be mentioned drops. N drops are combined to form a big capacitor. Charge on these capacitors, okay, is small q, small capacitors. Capacitance is C, potential is V, and radius is R. When you join these to form a big capacitor, you have to tell me what is the capacitance of the big capacitor, that is C dash. Directly remember, my dear NEET aspirants, capacitance of this big capacitor is going to be N raised power 1 by 3 into C. Capacit potential V dash is going to be N raised power 2 by 3 into V. V is the potential of the small capacitor. Charge will be N times of Q, the number of capacitors multiplied by Q. And this radius is going to be N raised power 1 by 3 into radius of small capacitor. These are the four things that you guys are supposed to remember in this particular case. That's it. Let's move on to the question. Now take a look at this question. 27 drops of small size are charged at 220 volts. You have got 27 drops. So value of N is 27. I told you sometimes it would be mentioned drops. Now these are combined to form a big drop. These are combined to form a big drop. And potential of these drops is given as 220 volts. You guys are supposed to tell me the potential of the big drop, V dash. You can simply say N raised power 2 by 3, N raised power 2 by 3 into V. Now boys and girls, you tell me one thing. You can say V dash is equal to N. What is the value of N? N will be over here, that is 27. Raised power 2 by 3 into V. V is the potential of smaller drop. So that is going to be 220, my dear NEET aspirants. Okay. Now tell me, can I write this V dash over here? 27 means 3 cube. 3 cube whole raised power 2 by 3 into, I would say, 220. Now boys and girls, you tell me in this particular case, 3 and 3 will be cancelled. 3 square is 9. 9 into 220. So this potential will be 1980 volts. This is going to be the potential in this particular case. Guys, tell me, is this clear? Is this clear, boys and girls? Smash the like button. Everybody out there. Next, 3 small bubbles, okay? 3 small bubbles. Identical bubbles of water having charge, same charge, okay? 3 small bubbles are right now given. Now, these bubbles are combined to form a big bubble, okay? To form a big bubble. Then the ratio of the potential on the initial bubble to ratio on the potential of the resultant bubble. Now guys, see, if I say in this particular case, what is the potential of this small bubble over here? Consider that V. What is the potential of this big bubble? You say, sir, this will be V dash. And this V dash in this particular case, consider it V2 or this is V dash. You can say it will be N raised power. N is over here, 3 raised power 2 by 3 into V. Because N is given how much? 3 bubbles. So value of N in this case is 3. Then it says potential, initial potential of the bubble divided by final potential of the bubble ratio. V1 divided by V2. It will be V upon, I would say 3 raised power 2 by 3 into V. V and V will be cancelled. So it will be 1 upon 3 raised power 2 divided by 3. So this is going to be the answer in this particular case. I hope this is also crystal and clear. Yes. Let's take a look at this particular question. This is the question from Magnetism, my dear NEET aspirants. This is a question from magnetism, my dear NEET aspirants. Now, in this particular case, you guys are supposed to tell me what is the magnetic field at the center. What is the magnetic field at the center? Listen to me very carefully. Now, in this particular question, if we see, you have got one wire, second wire, third wire. And guys, this is given as Z axis because in the question it is mentioned as Z. This is Y and this is X. Now, this is a semi-infinite wire because it is going till infinity from one end. This is also semi-infinite wire. This is a semicircular wire. It is something like this. There is a wire basically which is coming towards the board and then it is moving. This is a semi-infinite wire coming towards the board. Then this semicircular wire is being created over here. Then this is the wire which is leaving the board. Okay. Now, my dear NEET aspirants, in this particular case, what I am trying to say is you have to tell me net magnetic field at the center. Magnetic field will be created due to this semicircular wire, due to this and due to this. This is a semi-infinite wire, semi-infinite and semicircular. Let's see. Now, when it comes to the net magnetic field, my dear NEET aspirants, we say magnetic field due to semicircular wire. So, sorry, semi-infinite wire. Magnetic field due to semi-infinite wire is mu naught I divided by 4 pi into R. Because distance from this semicircular wire to the center, it is given as R. Now the direction, how do we find the direction? Place your thumb along the direction of current. Since it is going into the board, curl your fingers at point O. It is showing downwards. Now upward is plus Z. Downward is minus Z. So minus Z means minus, I would say, K cap. Because along Z direction, we mention what? K cap. So since it is downward, that is minus Z, so that's why minus K cap. Then magnetic field due to the semicircular wire. So magnetic field due to the semicircular wire will be mu naught I divided by 4R. This is the magnetic field due to the semicircular wire. Now let's find the direction. How do we find the direction? Sure. Curl your fingers along the direction of current. Okay, in case of this semicircular wire, curl your fingers along direction of current. Thumb is pointing inwards. So in this particular case, it is inward. Now guys, see, outward is plus X, inward is minus X. And along X direction, we mention I cap. So it is going to be minus I cap. Then my dear NEET aspirants, plus. What is the magnetic field due to this semicircular wire? It is going to be mu naught I divided by, again, 4 pi R. 4 pi R. Now what is going to be the direction? Place your thumb along direction of current. It is going outwards. And curl your fingers at this point. At this point. So my dear NEET aspirant, it is downward. Upward is plus Z. Downward is minus Z. So again, I would say it is minus K cap. Now we are done with the question. This and this will be twice. So first of all, you take the minus common. So this and this will be twice. So it will be 2 times of, I would say, mu naught I divided by 4 pi R. Then my dear NEET aspirants, here you can say plus because this minus is also taken out. Okay, and this would be K cap because this is K and this is K. And this, in this particular case, this is going to be mu naught I divided by 4R and this is I cap. Even you can take this also common in this particular case, or see, take this mu naught I by 4 pi R common, mu naught I by 4R. No, this is 4R in this particular case. You can take mu naught I by 4R common. 1 by pi will remain here. So here it remains 1. So K plus I cap. Okay, you can basically write it like this. Next, my dear NEET aspirants. Next, my dear NEET aspirants. Next, my dear NEET aspirants is this question. Is this clear till over here? Give me the signal in the chats. Is this clear till over here? Give me the signal in the chats, everybody. Tell me. Is this clear? Now, what does this question actually say? 6 charges plus Q minus Q plus Q minus Q plus Q minus Q. Okay. Are fixed at the corners of a hexagon of side D. There is a hexagon. This is having the side D as shown in the figure. The work done in bringing a charge Q0 to the center of the hexagon from infinity. Guys, this Q0 charge was exactly at infinity. So we are bringing it to the center. It says how much work has been done in bringing the charge from infinity to center. Always remember, whenever we say work done will be change in potential energy. Change in potential energy means final potential energy minus initial potential energy. Now, my dear NEET aspirants, when I say initial potential energy will be U infinity, and that is 0. Okay, that is 0. So boys and girls, why? Because at infinity, we consider potential energy as 0. Now, what I want you to understand in this particular case, my dear NEET aspirants, what I want you to understand over here is, finally the charge is at center. So final potential energy will be, now see, when this charge is at center, you can say potential energy between these two, potential energy between these two, potential energy between these two. Positive first. So tell me, what is the final potential energy? Between this and this potential energy, it is going to be K, Q1, Q2 by R, Q1, Q2. So it is going to be Q, Q0 divided by, what is the distance between the two? That is D. Because if this side is D, this is going to be D also. What is the potential energy between this and this? Same, K, Q, Q0 divided by D. What is the potential energy between this and this? Same. So how many times? 3 times. Okay, yes. Then could you please tell me what is the potential energy between this and this? Minus, because it is minus. K, Q, Q0 divided by D. So it is going to be minus K, Q, Q0 divided by D. This is the potential energy of positive charges. This is the potential energy of negative charges. Now with this negative also, it is going to be same. K, Q, Q0 divided by D. With this also. So this also came out to be 3 times. Now, don't you think that this positive and this negative will be cancelled? So final potential energy is also how much? 0. So when it comes to the work done, you say final potential energy minus initial potential energy, it is going to be 0. It is going to be 0. Is this clear? I believe this is crystalline clear. Now take a look at this particular question. Take a look at this particular question. See guys, electric field in a region is given by, this is the electric field which is given. That is AX, it's in the vector form, AX I cap plus BY J cap. Value of A and B are given. If the potential at a point, so potential at this point is given as 500 volts. You have to tell me potential at the origin. Guys, see, listen to me very carefully. Let's suppose this is the origin. It says that potential at this point is given. What is the coordinate? That is 10, 20. Potential at this point is 500 volts. Okay. And electric field in this region is given something like this. This is the electric field. And potential of this point is given. You are supposed to tell me what is the potential at the origin. This potential. Very important question. Very good question, I would say. Now guys, what I want you to understand, guys, make sure you smash the like button. Liking the session is mandatory. What I want you to understand, when electric field is given, you are supposed to find potential or potential difference. Understand one thing. We say as potential difference delta V is equal to negative of, I would say, E, and then we say, I would say in this particular case, dr. Okay, EDR. This is the equation which you guys are supposed to apply over here. Now, my dear NEET aspirants, listen to me very carefully. What I can say over here, potential difference will be minus integration of, instead of electric field, I'll be writing this AX into I cap plus BY into J cap, and then you can say, or you can directly write it like this, my dear NEET aspirants. You need to integrate this with respect to X. So I would say AX into DX plus, then we say integration of this B into Y, and then we say dy. Okay. And my dear NEET aspirants, listen to me very carefully, guys. Electric field is given. You are supposed to find potential difference. Now, here electric field is given in terms of X as well as Y. So you will have to do the integration with respect to x as well as y. And this is origin. What is the coordinate of origin? 0, 0. Now, what is the coordinates of this point? Because for this point, potential is given, that is 10, 20. This is the x coordinate, this is the y coordinate. So here you will be saying you will have to do the integration from 0 to 10 because x coordinate is 10. And here is 0 to 20 because y coordinate is 20. Now, my dear NEET aspirants, further you would be like minus. Tell me, what is the integration of ax? So it is going to be ax square divided by 2. And. The limits are from 0 to, I would say, 10. Then plus. What is the integration of by? It is going to be by square divided by 2. Now, what are the limits in this particular case from 0 to 20 in this particular case? So basically, my dear NEET aspirants, you are calculating this potential difference between this point and this point. Now, value of A is also given, that is 10. Value of B is 5. So delta V you can write over here minus. Tell me, value of A is 10. So 10 into. Now, in this x, you will be putting the upper limit. 10 square is 100 divided by 2. 2 ones are 2 50s are. Then plus B. What is the value of B? B is 5. And what is the value of Y? Y you need to put over here into 20 square. That is 400. In this Y you need to put 20. 20 square is 400 divided by 2. 2 into, I would say, 200. Now, this delta V, my dear NEET aspirants, is, I would say, over here, negative. Now, how much is this over here? Listen to me very carefully. This is 5 into 200 is 1000. 1000 plus, this is 50. 50 into 10 is 500. So this is going to be minus 1500. So you got the value of potential difference between this point and this point as minus 1500. So you can say this potential difference, delta V, it is given as minus 1500. Now this potential difference will be potential of this point minus potential of this point. So that will be potential of this point is given as 500 volts minus potential at origin will be equals to minus 1500. So can you take it over here? So this will be, if you take it over here, if you take it over there, so this will come out to be 2000. Right? This is minus 1500. If you take it over there, it will become plus 1500. 1500 plus 500 is 2000. So if you take it over here, this will be the potential at origin. Guys, please tell me if this is crystalline clear. Please tell me if this is crystalline clear. Tell me, quick. Smash the like button if you're not liked the session yet. So basically, electric field was given. And electric field was given in terms of X, in terms of Y. That's why you integrated. So this is the formula. This is the general formula. You have to find the potential. So when potential you have to find, electric field is given, you integrate. Now, since electric field is given in terms of X as well as Y, that's why you integrate it separately with respect to X, separately with respect to Y. Now, between this point, origin, and this point, potential of this point is given. So coordinate is given as 10, coordinate is given as 20. That's why from 0 to 10, 0 to 20. Now, let's move on to the next question. Very important. Guys, when it comes to the chapter electrostatics, 5 questions are asked from the chapter electrostatics. Keep that thing in your mind, my dear NEET aspirants. This question is very important. Very, very important, my dear NEET aspirants. Two conducting spheres of radii A and B. You have got two conducting spheres of radii A and this is B. Are connected to each other by means of a wire. They are connected to each other by means of a wire. The ratio of electric fields at the surface of two spheres is, guys, you have to tell me electric field at the surface of first divided by electric field at the surface of second. This ratio you guys are supposed to tell me. Now tell me one thing, boys and girls. In this particular case, whenever two spheres are connected by means of a wire, always remember their potential becomes equal. Potential of this becomes equal to potential of this. How do you find the potential of this? It is going to be K. We don't know the charge over here. Let's assume Q1 divided by, I would say, A. A means its radius. Because potential at the surface of a hollow sphere is KQ by R. R is the radius. is equal. Potential of this sphere is going to be K Q2 divided by B, because radius of this is B, KQ by R. Now, this K and K will be cancelled. Take it over there. So I can say Q1 divided by Q2 will be equals to A divided by B. Okay. Now, my dear NEET aspirants, what I want you to understand, keep this first equation. Now, if I say electric field on the surface of first divided by electric field on the surface of second, what is the electric field on a surface of conducting sphere, means hollow sphere? So that is KQ by R square. KQ1 divided by R square, radius square. What is the radius over here? That will be A square divided by potential on the surface of this sphere. That is KQ2 divided by R square. Radius square is B square. Now this, okay, wait. This and this will be cancelled. So it will be Q1 divided by A square into B square divided by Q2. So can I say this E1 divided by E2, my dear NEET aspirants, will be? Now, Q1 by Q2, instead of Q1 by Q2, you can write A divided by B. Instead of this Q1 by Q2. Then you can say this B square by A square. So B square divided by A square. Square and this will cancel, square and this will cancel. So it is going to be B divided by A. So answer in this case is option second, that is B divided by A. Okay. Yes, yes, yes. Now guys, this question. The question here is, three identical bulbs are connected as shown in the figure. A, B and C. These are the three bulbs connected as shown in the figure. Okay. The power consumed by the bulb B is P. The power consumed by this bulb B is P. Okay. Yes. Okay. When the switch S is open, the power consumed by this bulb B is P. So I'll just write over here, my dear NEET aspirants, when switch is open, listen to me very carefully. When switch is open, at that point of time, my dear NEET aspirants, this circuit is open. So no current will flow through this bulb, so this will not work. Only these two bulbs will work. So the circuit would look something like this. The resistance of this bulb is R, resistance of this bulb is R, and this is E. So when switch is open, the bulb will look something like this. So can I say in this particular case, my dear NEET aspirants, when it comes to the potential difference, let's suppose X potential CCC. In series combination, potential difference of the battery is divided between the two loads. So half of the potential difference will go here, half will go here, or I would say some portion will go here. Because resistance and resistance is same. Na? A potential difference, this battery is giving 50 volts to this. It has to give 50 to this also. So I can say this X plus X, that is going to be 2X. This has to be equal to this E. So X will be equals to E divided by 2. Now, if I ask you what is the power consumption by this bulb, this is actually B1, this is B. So power consumption by this bulb, okay, this is going to be, that is power is equal to V square by R. Now, power in this particular case is V square. What is the potential difference across this? That is E square divided by 4, and then we say R. E square by 4R. E square by 4R. Now, my dear NEET aspirants, can I write it like this? Take this 4P over here. It will come out to be, that is E square divided by R. Consider this first equation. Because it says that when the switch is open, power consumed by the bulb B is P. That P we can write it something like this. E square by 4 into R. Then it says the next portion, what will be the power consumed by the same bulb when its switch is closed? So second is when switch is closed. When switch is closed. So my dear NEET aspirants, if you close the switch, then the circuit would look something like this. This is R and this is R. This is R. Now this R and this R will be in parallel. So their equivalent is going to be R by 2. Because when the two resistors are in parallel, their equivalent is R by 2 if they are similar. So then circuit would look something like this. So basically this is going to be R by 2 and this is going to be R. This is E. Now, my dear NEET aspirants, we can say this potential difference will be divided between this and this. If I say potential difference across this will be X, across this it is going to be 2X. Why? Because R is double of R by 2. So what I can say in this particular case, my dear NEET aspirants, this plus this must be equal to this. So X plus 2X, this potential difference plus this has to be equal to this E. So this will be equals to 3X is equal to E. So X will be equals to E divided by 3. So means when the switch is closed, at that point of time, potential difference across this bulb B, it is going to be how much? That is E divided by 3. Now tell me what is going to be the power finally. You say, sir, power finally P dash. It is going to be, that is V square by R. What is the potential difference finally across it? That is E square divided by 9. Why? Because V is this. This is E by 3. Across this, it will be E by 3. So E by 3 whole square, that is E square by 9. So can I say, array, this 4, I am taking this 4P over here. So this is E square by 9 into resistance of this bulb. Bulb B is actually R. Now tell me, my dear NEET aspirants, so this P dash will be equals to E square by R. What is the value of E square by R? 4P. So you can say it is going to be 4P divided by 9. So this is the power consumption finally when the switch is closed. Please tell me if this is clear. Please tell me if this is clear. Guys, come on, quick. Is this clear? Smash the like button if you're not like the session yet. That's great. That's great. That's great. Okay, now see this. A filament bulb 500 watt at 100 volts. There is a bulb over here. Okay, it is 500 watts and 100 volts. Is to be used in a 230 volt supply. So there is a 230 volt battery applied to this, where resistance R is connected in series, where resistance R is connected in series. Okay, this resistance R is connected in series. It works perfectly and consumes 500 watts. The value of resistance is. Now guys, see. If this bulb has given over here, what is the wattage of this bulb? It is 500 watts. So means this bulb can provide us the power of 500 watts. This bulb can provide us the power of 500 watts. If we supply 100 voltage, now guys, see, if 230 volt supply is connected over here, so this 230 volt is going to send 100 volt to this. Why? Because this has the maximum capability, how much it can take, that is 100 volt. So rest 130 volts will go into the resistance. Now from this you can say power is equal to V into I. This is also the formula of power. Now you have to find the resistance R. Find the current first. So power, what is the power of this bulb? This is 500 watts is equal. Voltage of this bulb is 100 into I. 0, 0, 0, 0 will be cancelled. So I will come out to be 5 amperes. Now my dear NEET aspirants, if we don't apply, if we don't connect the resistance in series over here, then 230 volt is directly connected to this bulb. So this is going to burn the bulb. Bulb will fuse. Why? Because maximum capability it can take is 100 volts. You are sending 230 volts. It is going to burn the bulb. That's why we are using the resistance in series. So it is going to take only 100 because its maximum capability is 100. Rest of 130 will go into the resistance. Now, if we, my dear NEET aspirants, find the current over here, current is 5. So same current, this is in the series, same current will flow through here. So now tell me, we can use the Ohm's second law. Ohm's law, V is equal to I into R. I will be equals to V divided by R. Now, what is the potential difference across this? 130. Okay. Okay, current is given. You are supposed to find R. R is equal to V by I. So this is 130 and current over here is given as 5. So this will be 26 ohms. So this is going to be 26 ohms. I hope this is also crystalline clear. Guys, from the current electricity chapter also 5 questions are expected. Okay, high weightage chapter. Take a look at this particular question. Take a look at this particular question. In an ammeter, 0.2% of main current passes through the galvanometer. There is an ammeter. Ammeter means in which there is a galvanometer and a shunt resistance in parallel. This whole is called ammeter. In an ammeter, 0.2% of main current passes through the galvanometer. Let's suppose main current which is entering the ammeter is I. It says only 0.2% enters over here. That is 0.2 I. So how much is the remaining? I would say 99.8 I will go in this. Okay. So how much current passes through the galvanometer? That is 0.2 I. So how much is the remaining 99.8 I? That passes through the shunt. Now what I'm trying to say in this particular case, if the resistance of the galvanometer is G, resistance of this galvanometer is G, then the resistance of the ammeter will be, resistance of galvanometer is G. Then you have to find the resistance of ammeter. That means resistance of this plus resistance of this, means they are in parallel, they're equivalent. Guys, see, first of all, let's find shunt. Let's find shunt. Then only you can find the resistance of the whole ammeter. Na? How do you find shunt? You say shunt is equal to Ig into G upon I minus Ig. This is the way by which we find the shunt resistance. So I can say S is equal to Ig into G. Ig is the current which passes through the galvanometer. How much is the current passing through galvanometer? 0.2 I. So 0.2 I. This is the value of Ig. This is I. This is Ig. Current going through galvanometer. What will be remaining? This will be how much? I minus Ig. This is I. This is Ig. This will be how much? I minus Ig. So into G divided by I minus Ig. Value of that is 99.8 I. Now tell me, how can we write this? I and I will be cancelled. So S will be equal 0.2 means 2 divided by 10G upon 99.8 means 998 divided by 10. Because after the decimal point, you have only one digit. 10 and 10 will be cancelled. 2 ones are 2, 499s are. So shunt will come out to be G divided by 499. G divided by 499. This is the shunt. Now you have to find the resistance of ammeter, my dear NEET aspirants. So this is the resistance of galvanometer. This is the resistance of shunt. This is G. This is G divided by 499. This as a whole is considered as ammeter. Now in this ammeter, this G and G by 499 are in parallel. When two resistors are in parallel, so their equivalent resistance is R1, R2 upon, I would say R1 plus R2. You can say it like this. Now R1, R2. R1 is this, R2 is this. So you can say G into G divided by 499 upon G plus G divided by 499. Now how much this is going to be? G square divided by 499 upon 499G plus G. This will be 500G divided by 499. 499, 499, G and this square. So resistance of ammeter came out to be, that is G divided by 500. Guys, please tell me how many of you understood this question. Quick. Tell me, guys. Tell me. Is this clear? Oh, tell me, guys, quickly in the chats. Is this crystalline clear? Now, boys and girls, tell me one thing. A straight finite wire carrying a straight wire of finite length carrying current I subtends an angle of 60 degree at a point as shown in the figure. The magnetic field of this point is, guys, this is a wire I, this is a wire in which current I is flowing. I'll make this diagram over here. This is the wire in which current I is flowing. And this is the point over here. At this particular point, my dear NEET aspirants, you have to tell me magnetic field. Sir, what about these two? Are these two also the wires? Are these two also the wires? No. This is the distance x from one end to that point. This is also the distance x. This angle is given as 60. Now see, if I say, my dear NEET aspirants, this total angle is 60. How much is this angle? 30. And how much is this angle? 30. You have to tell me what is the magnetic field due to this wire at this particular point. Now listen to me very carefully. There is a formula by which we find the magnetic field due to a finite wire. Formula is B is equal to mu naught I divided by 4 pi r. Then we say sine of theta 1 plus sine of theta 2. This one. Now, this you will be considering as theta 1. This is considered as theta 2. So, theta 1 is equal to theta 2 is actually equals to 30 degrees. This is theta 1 and theta 2. And my dear NEET aspirant, this r is the perpendicular distance. This r is not given. Let's find the value of r. Can you tell me what is the value of cos theta from this? Cos of 30 from this triangle? Cos 30 is base. This will be base upon hypotenuse. Base over here is given as r. Hypotenuse is given as x. What is cos 30? That is a root 3 divided by 2 is equal to r divided by x. Take this x over here. R will come out to be a root 3x divided by 2. Sir, is x given in the question? Obviously, see, x is given in the question. Now, put it over here. So, this magnetic field is going to be mu naught I divided by 4 pi. Instead of r, you can write a root 3x divided by 2. And then sine of theta 1, that is sine 30 plus sine 30. Theta 2 is also 30. Now 2 1s are 2 2s are 4. So magnetic field will come out to be mu naught I divided by 2 pi root 3 into x. Sine 30 is given as 1 by 2 plus sine 30 is given as 1 by 2. 1 by 2 plus 1 by 2 is 1. So magnetic field is going to be mu naught I divided by 2 pi root 3 into x. Mu naught I divided by 2 pi root 3 into x. Mu naught I divided by 2 pi root 3 into x. This one. This one. This one. The figure shows a current carrying loop having the circular arcs joined by two parallel radial lines. The magnetic field at O is. Guys, see. Let me make the diagram over here. Okay. Okay. Now, guys, this one. This radius is given as A and this radius is given as B. Okay. So basically current in this is given as I and current in this is given as I. This radius is A, this radius is B, and this angle is theta. You have to tell me what is the magnetic field due to this wire and this wire. Net. Now see. Net magnetic field in this case will be, guys, is this a semicircle, chord, or complete circle? Sir, it is an arc. Arc means some portion of the circle, some portion of the ring. And what is the magnetic field due to an arc? We have studied it is mu naught I divided by 2r, theta divided by 2 pi. This one. Now, guys, listen to me very carefully. If I say this is an arc, let's find the direction of magnetic field. How do we find the direction of magnetic field? Curl your fingers along the direction of current. Thumb is pointing outwards. So magnetic field due to this at center will be outwards. Okay. So consider this 1 and consider this 2. Okay. So this will be magnetic field due to 1 and magnetic field due to 2. This is outwards. Outward means dot. Let's find the magnetic field due to this. Curl your fingers along direction of current. Thumb is pointing inwards. So magnetic field due to this second, it is inwards. So if one is outward, another is inward. So you need to put the minus because they are in the opposite direction. If the two magnetic fields are in the same direction, in that case, you need to put plus. Here you need to put minus. Okay, yes. Guys, smash the like button. Quick. Now, guys, what you guys are supposed to apply over here, magnetic field due to an arc. So when I say net magnetic field in this case, magnetic field due to this one, it is going to be mu naught I divided by, I would say 2r theta by 2 pi. And what is the value of r, by the way? What is the radius of this? That is a. So 2a theta divided by 2 pi minus. What is the magnetic field of this? Mu naught I divided by 2r. What is the value of r for the second one? That is b. Then theta divided by 2 pi. Okay, 2b theta by 2 pi. Now what can you take common over here? Mu naught I divided by 2 into 2 is 4 pi. Okay. And theta also common. So it will be 1 divided by a minus 1 divided by b. So this is going to be mu naught I into theta divided by 4 pi. Now do the cross. B into 1 is b minus a into 1 is a divided by a into b. I can say it something like this. This is going to be the net magnetic field, boys and girls. Okay. Mu naught I into theta upon 4 pi. Mu naught I into theta upon 4 pi. B minus a upon ab. Second option. Second option. Okay. Yes. Yes, absolutely. Absolutely. Take a look at this question. This is the question from EMI, electromagnetic induction. Now, guys, see. Find the flux through the square loop. This is a wire, infinitely long wire in which current I is flowing. And there is a square loop present at a distance. You have to tell me how much is the flux through this. Guys, see. If I say, will this wire create any sort of magnetic field? Yes. How? Place your thumb along direction of current, curl your fingers. So magnetic field due to this wire is inwards. Inwards. And this magnetic field due to this wire, it is inwards. And this inward magnetic field is crossing the loop. So whenever magnetic field crosses the loop, it creates flux. Now see, how do you find the flux over here? Sir, since, guys, if I say, you say flux is this, magnetic field into area. Now the question over here is, area, we know area of this loop, that is L square. What will you take magnetic field? Sir, magnetic field due to wire is mu naught I divided by 2 pi into r. R is the distance. Now, if you say at this point magnetic field will be mu naught I divided by 2 pi into a, because from here distance is a. Sure, I would say magnetic field will be mu naught I divided by 2 pi into a plus L by 2, because this distance is L by 2. At this point, magnetic field is going to be mu naught I divided by 2 pi into a plus L. 2 pi into a plus L. This one. So magnetic field from this point to this point is variable. It is not constant. So what will I do in this? So I cannot use this formula directly. So what will I do? I will take a small, infinitely small strip in this case, which has a width, I would say dx. Infinitely small strip, it has got width dx. Now, my dear NEET aspirants, from here to here, let's suppose this is at x distance. This small strip is present at a distance of x from the wire. This small strip is present at a distance of x from the wire. If I ask you, what is the magnetic field? Listen to me very carefully. What is the flux created through this? You say, sir, flux through this. That is going to be d phi, small flux. And that will be magnetic field into area. Area of this will be dA. Sir, at this x distance, will the magnetic field be constant? Yes. Magnetic field due to this wire at x distance will be constant. No doubt from this point to this point, it is going to be variable, but at a particular point, it is going to be constant. So I can write this small flux d phi because through the small strip, magnetic flux will be small and length is L. So it is going to be magnetic field, that is mu naught I divided by 4 pi r. Instead of r, I can say x because this is at a distance of x. And then, my dear NEET aspirants, dA. dA means over here, that is area of this. What is the area of rectangle? Length into breadth, that is L dx. So this is the magnetic flux created through this small strip. If you want to find the magnetic flux from this point to this point, total flux. So to find total flux, pi net, we integrate. So if you integrate over here d phi, integration of d phi, it will be integration of mu naught I divided by 4 pi x, and then we say L into dx. Now, boys and girls, what I would say over here, integration of d phi will be net flux. It is equal to, and guys, you have to find the flux from this end to this end. This end is at a distance a. This end is at a distance of, this is L plus a. So this is from a to a plus L. So what I can say in this particular case, this mu naught will be out because this is constant. This current is out, this is constant. Okay, this length, this L square length is constant, divided by 4 pi is constant. What is variable? 1 by x. So 1 by x, and then we say dx. From where to where? I would say from a to a plus L. So I can say, my dear NEET aspirants, in this particular case, net flux is going to be, I can say mu naught I into L divided by 4 pi. Integration of 1 by x. What is the integration of 1 by x? Integration of 1 by x is, I would say, ln of x. From where to where? From a to a plus L. So what I can say in this particular case, net flux is going to be mu naught I into L divided by 4 pi. So then you can say ln of, see, for this x, you can say a plus L, put the upper limit first, divided by a. A plus L divided by a. Is this clear, boys and girls? Is this clear, boys and girls? Please let me know in the chats if this is clear. Is this clear? Okay. This is a question from modern physics. Very important question. Question from photoelectric effect. Question from photoelectric effect. Tell me, is this clear? Now take a look. For a metal, frequency F is 5 times the threshold frequency. You have got a metal surface over here. Listen to me very carefully. Its threshold frequency over here is F naught. Threshold frequency means minimum frequency at which the photoelectric effect takes place. Okay. For a metal, frequency is 5 times threshold frequency. The maximum velocity of the photoelectron is 8 into 10 raised power 6. It says that there is a photon which is falling on this photosensitive metallic surface. And when the photon falls on the photosensitive metallic surface, electrons are ejected from the metal surface. Electrons are ejected from the metal surface. Now, my dear NEET aspirants, what is the frequency of this photon? Frequency is given as, I would say, 5 times of F naught. So 5 times of F naught, 5 times the threshold frequency. And velocity of this photoelectrons is given as how much? I would say 8 into, this is V1, 10 raised power 6. Then the questioner says in this particular case, if frequency of the photon becomes 2 times threshold frequency. If you send the photon which has the frequency equal to 2 times threshold frequency, then in that particular case, velocity is going to be, what is the velocity of the photoelectron? What is the velocity of the electron which is coming out? Now, in this particular case, we can use what? We can use Einstein's photoelectric equation. Use Einstein's photoelectric equation. Photoelectric equation. What does that say? Energy of a photon is equal to work function plus kinetic energy maximum. This is the equation. Energy of a photon is equal to work function plus kinetic energy maximum. Energy of a photon, you can say h into f is equal to, this you can write over here, h into f naught. This is the value of work function. Plus kinetic energy, you can write 1 by 2 mv square. Now apply this formula in case 1, in case 2 also. Now guys, see, if we apply the same formula in case 1. So h into f, what is the frequency in case 1? That is 5 times of f naught. So instead of f, I can write 5 times of f naught. So this will be 5 h into f naught will be equals to. Then hf naught plus 1 by 2 m. Boys and girls, when this frequency photon falls, electron velocity of electron is v1. So 1 by 2 m v1 square. Consider, okay. So take it over here, 5 minus hf naught. This becomes 4 hf naught is equal to 1 by 2 m v1 square. Now apply the same equation in case 2. So when you apply the same equation in case 2, now tell me, in case 2, what is the frequency of the photon? 2 times f naught. So this will be 2 times hf naught is equal to hf naught plus 1 by 2 m v2 square. Take it over here. 2 times hf naught minus hf naught. It is going to be hf naught is equal to 1 divided by 2 m v2 square. This is the second one. This is the first one. Now divide first and second. So I can divide first and second over here. Divide first and second equation. When you divide first and second equation, so this is 4 hf naught divided by hf naught, my dear NEET aspirants, will be equals to 1 by 2 m v1 square divided by 1 by 2 m v2 square. Now boys and girls, 1 by 2 m, 1 by 2 m, hf naught. So I can say v1 divided by v2 will be equals to, take the square over here, my dear NEET aspirants. So this will become a root of 4. Root 4 is actually 2. So we are supposed to find the value of v2. So v2 will be equals to v1 divided by 2. What is the value of v1? 8 into 10 raised power 6 divided by 2. So this will come out to be, v2 will be 4 into 10 raised power 6, my dear NEET aspirants. This question. Take a look at this question, guys. The energy of hydrogen atom in ground state is same as helium in first excited state. Of helium in first excited state. Guys, see. What is the energy of an electron in the nth orbit? You say, sir, it is minus 13.6 z square by n square. Okay, yes. This is the energy. Now it says that if the photon, guys, if the electron is revolving in the hydrogen atom, guys, see, for hydrogen atom, listen to me very carefully. We say, what is atomic number 1? And it says ground state. If electron is revolving in hydrogen atom in the ground state, so means n is equal to 1. What will be the total energy? You can say total energy will be minus 13.6, 1 square divided by 1 square into 1 square divided by 1 square. So energy will come out to be minus 13.6 electron volts. Now, if I say, it says the energy of the electron in the ground state of hydrogen atom is same as the energy of electron in the first excited state of helium. Now, if I say for He. What is the atomic number? 2. First excited state means second orbit. So second orbit means n is equal to 2. What is the energy of the electron over here? Minus 13.6 z square by n square. So z square is 2 square, n square is 2 square. For this and this will cancel. So energy will come out to be minus 13.6 electron volts. Okay. So my dear NEET aspirants, option A is correct. Similarly, you have to check for option B. You have to check for option B. Now see, let's check the option B. The energy of hydrogen atom in the ground state, energy of hydrogen atom in the ground state, we already checked, is same as that of Li2 positive ion in its second excited state. Now see, for Li2 positive, we say what is the atomic number? 3. And it says second excited state. Second excited state means third orbit, means n is equal to 3. What is the energy over here? That is minus 13.6 z square by n square. That is 3 square divided by 3 square. This and this will cancel. So this will be also minus 13.6 electron volt. Means this is also correct. So A, B is correct. Then you check the rest of the options in this particular case. A and B is the correct. So C option. Energy of the hydrogen atom in the ground state is same as in the ground state of helium. Incorrect. Energy of the helium in its first excited state, okay, is same as energy for lithium in its ground state. Guys, helium. What is the atomic number of helium? Check this. Atomic number of helium is 2 and it says first excited state. First excited state means n is equal to 2. So when it comes to the energy, that will be 13.6. Okay. And when it comes to the Li2 positive, so it will be Z is equal to 3 and its ground state n is equal to 1. No, this is also incorrect. So A and B are correct. Take a look at this. For a hydrogen atom, the ratio of the largest wavelength, okay, for a hydrogen atom, the ratio of the largest wavelength of Lyman series to that of Balmer series. Now see, when I say Lyman series, when I say Balmer series, so largest wavelength, guys, when it comes to the first line of Lyman series, it has got minimum energy, minimum frequency, but wavelength is largest. So means that is the first line. Always remember, first line has largest wavelength. Here also first line. So first line has largest wavelength, last line has lesser wavelength. Now, my dear NEET aspirants, how is the first line in Lyman series created? When we say n final is 1, because finally when electron moves to the first orbit, from n initial, that will be from n is equal to 2. When an electron makes the transition from second orbit to the first orbit, then we say first line of Lyman series is created. Here we say final orbit is 2, initial orbit in this particular case is 3. So my dear NEET aspirants, when it comes to this, we can say 1 divided by lambda Lyman. It will be Rydberg constants. 1 by n final square minus 1 by n initial square. Now, boys and girls, what I want you to understand over here, 1 divided by lambda Lyman will be equals to Rydberg constant R. Now, 1 by n final square. N final is 1 by 1 square minus 1 divided by 2 square is 4. So 1 divided by lambda Lyman will come out to be, this is R. 4 minus 1, that is 3 divided by 4. So this will be, lambda Lyman will come out to be 4 divided by 3R. Because this is 4 minus 1 is 3, 3 divided by 4. This is lambda Lyman. Now, if I say lambda Balmer, How do we find this? This will be R. 1 by n final square. N final is 1 by 2 square, that is 1 by 4, minus 1 by n initial square. N initial is 3 square, that is 9. So 1 divided by lambda Lyman will come out to be R. This is 9 minus 4, that is 5, divided by, this is 36. So 1 divided by lambda Lyman, do the reciprocal. Lambda, this is Balmer. So lambda Balmer will come out to be 36 divided by 5R. Now what does the question say? It says lambda of Lyman divided by lambda of Balmer. For Lyman series, it is 4 divided by 3R into. For Balmer series, it is going to be 5R divided by, I would say 36. R and R will cancel. 4 ones are, 4 nines are, 3 nines are 27. So 5 divided by 27. So 5 is to 27 is the correct option. Similar question on this one. Even this question was also asked in JEE 2025. Okay. The ratio of the shortest wavelength of Balmer series to the shortest wavelength of Lyman series. Okay. So I can say when it comes to the shortest, guys, first it says Balmer series. Balmer. And then it says Lyman. Now, longest wavelength, which line has got the longest wavelength? First line. And when it comes to the shortest wavelength, it means last line. Here also it means last line. It means last line. Okay. Now, boys and girls, what I can say over here, how is the last line created? Last line of Balmer series is created when I say n final. Final orbit, when I say n final, final orbit, in this particular case is 1. And initially electron has come from, I would say, infinity. When electron makes the transition from infinity to first line, okay, oh, this is Balmer, and final has to be 2. When an electron makes the transition from infinity to second orbit, that means the last line of Balmer series. When an electron makes the transition from infinity, so n initial is infinity, to n final is equal to 1. So that means the last line. That means the last line of Lyman. Now tell me, how do we find this? 1 divided by lambda Balmer is equal to Rydberg constant. We have to find the wavelength. So R, 1 by n final square, 1 by 2 square is 4, minus 1 divided by infinity. 1 by infinity is 0. So 1 divided by lambda Balmer will come out to be R divided by 4. Do the reciprocal, lambda Balmer will come out to be 4 divided by R. And in this particular case, my dear NEET aspirants, if I say 1 divided by lambda Lyman, it will come out to be R. Then 1 by n final square, that is 1 divided by 1, minus 1 by n initial square, 1 by infinity. 1 by infinity is 0. So lambda Lyman will come out to be 1 divided by R. Now you have to find lambda Balmer divided by lambda Lyman. Lambda Balmer is basically 4 divided by R into lambda Lyman. If you take in the numerator, it will be R divided by 1. This and this will cancel, so it is 4 is to 1. So ratio in this particular case is 4 is to 1. Okay. This question. Now, what does the question say? A proton of mass mp has same energy as that of photon. There is a photon, it has got mass mp. Proton. Okay. A proton of mass mp has same energy as that of photon. Now guys, when it comes to a photon, in this particular case, okay, when it comes to a photon, so what is the energy of a photon? E is equal to hc divided by lambda. Can you tell me what is the value of lambda? E hc divided by E. This is the energy of a photon. This is how we write energy of a photon. H is Planck's constant, C is de Broglie's wavelength. Okay. Then it says, if proton has mass mp has same energy as that of photon. Okay. And if the proton is moving with non-relativistic speed, then the ratio of de Broglie's wavelength to that of the photon will be. To that of the photon of wavelength will be. This is photon. When we talk about proton, guys, energy is given. How do we find de Broglie's wavelength in terms of energy? Sir, that is lambda is equal to h upon under root of 2m into kinetic energy. Kinetic energy is given as E. So basically you have two particles. One is photon, another one is proton. This is PR and this is PH. And in this particular case, my dear NEET aspirants, it says that both have got same energy. You have to tell me what is the ratio of de Broglie's wavelength of, okay? Then the ratio of de Broglie's wavelength of the photon is, okay? Then the ratio of, okay, de Broglie's wavelength of proton divided by, a proton of mass mp has the same energy as that of photon of wavelength lambda, okay? Then it says, if the proton is moving with a non-relativistic speed, the ratio of de Broglie's wavelength to the wavelength of the photon, okay, it says de Broglie's wavelength of proton divided by de Broglie's wavelength of photon. What is this? So we calculated de Broglie's wavelength of photon, we calculated de Broglie's wavelength of, okay, proton. Now divide the two. De Broglie's wavelength of proton divided by de Broglie's wavelength of photon. So it is going to be h upon under root of 2m into E multiplied by, when you take this in the numerator, it will be E upon, I can say h into C. H and h will be cancelled. Now tell me guys, in this particular case, what I can write, 1 divided by C, okay? So in the numerator, this is E upon, this is going to be under root of 2m into E. 2m into E. Now do one thing, multiply with root E and divide with root E. So root E into root E becomes E. This E will be cancelled with this E. So 1 divided by C, this is going to be under root of E divided by 2m. Okay. E divided by 2m. Let's take a look at this question, guys. Okay. One thing I would want you guys to remember in this particular case. Guys, when it comes to the frequency is directly proportional to stopping potential. Okay. When it comes to the photocurrent, it is directly proportional to intensity. So means if intensity is same, photocurrent is same. Okay. And this frequency is proportional to the wavelength. If frequency is same, means wavelength is same. Now read the question very carefully. Which of the following variation take a look. Which of the following, which figure shows the correct variation of applied potential difference V with photocurrent at two different intensities? Which of the four graphs has, listen to me very carefully, different intensities? I1 has to be less than I2. Okay? Of same wavelength. Same wavelength means same frequency. Because when frequency is same, wavelength will be same. Now see. I'll directly check over here. Check at option B. In option B, this is called a stopping potential. So if stopping potential is same, it means frequency is same. If frequency is same, means wavelength is same. Yes. Okay. This is photocurrent versus potential. Now, this has got photocurrent different. This has got photocurrent different. Even this photocurrent is greater than this photocurrent. We say here, this I1 is less than I2. Intensity of this graph is less than intensity of this graph. So option C is the correct option, this option. Because we were supposed to find that graph where wavelength is same, okay, and intensity is different. And I1 is less than I2, so that is option B only. In this case, you see stopping potential is different. If stopping potential is different, so frequency is different, so wavelength is different. This question. For a photoelectric effect, the maximum kinetic energy Okay, maximum kinetic energy of the photoelectrons is plotted again as the frequency. Kinetic energy is plotted again as the frequency. Okay, of incident photons as shown in the figure. The slope of the given graph is, what is the slope of given graph? Listen to me very carefully. I'll make you understand. I'll make you understand. Guys, see, could you please tell me what is the equation of photoelectric? We say as when it comes to the Einstein's photoelectric equation. Listen carefully. What does that say? Energy of a photon is equal to work function plus kinetic energy maximum. Okay, yes. How do we write this energy of a photon? H into F is equal to work function plus kinetic energy maximum. Now tell me, take this over there. So kinetic energy will come out to be work H into F minus, I would say, phi. Guys, energy of photon we can also write Planck's constant into frequency. Now if you compare with y is equal to mx plus c. If you compare it with y is equal to mx plus c. Now guys, see, here you have kinetic energy, you have y. So on y-axis it must be kinetic energy, yes. Here you have x, you have frequency. So on x-axis there must be frequency, yes. Here you have m. M actually means slope. Okay. M actually means slope. And this slope in this particular equation is what we call h. That is, h means Planck's constant. Planck's constant. So means here in this particular graph, we say h is what? Slope is what? Planck's constant. H means Planck's constant. Is this clear? Now take a look at this question. Take a look at this question. Can you give me the answer to this particular question, guys? Come on. Can you give me the answer to this question? Smash the like button if you are not liked the session yet. Now guys, assuming the validity of Bohr's atomic model for hydrogen-like atoms, the radius of Li2 positive ions. Guys, listen to me very carefully. The radius of Li2 positive ions in this ground state. When I say Li2 positive, in this ion, what is the value of atomic number? That is 3. For Li2 positive, atomic number is 3. It says in its ground state means n is equal to 1. What is the radius? That is given. Radius is given. That is 1 divided by x into a naught. So this is the radius of an electron in the ground state of Li2 positive. Now tell me, we say as we know. Guys, we can say R is equal to R naught n square divided by z. This is the way how we find the radius. So R is equal to R naught. Instead of R naught, it has mentioned A naught. Mention A naught. N square. N is ground state. That is 1 square. Divided by Z. Z is given as 3. So R will come out to be 1 divided by 3 into A naught. Now compare this and this. Could you please tell me what is the value of x? X will come out to be basically 3 in this particular. This question, very important, and so many times they have asked this particular question. See, For a nucleus of mass number A and radius R, the mass density of the nucleus can be represented as, guys, see, when it comes to the density of nucleus, it does not depend, density of nucleus does not depend upon the mass number. Density of nucleus actually doesn't depend upon the mass number. Okay, so I would say option B is independent of. So my dear NEET aspirants, density of this nucleus is basically 10 raised power 17 kg per meter cube, and it is constant for all nuclei. Even sometimes questions were asked like this. This is a nucleus X, this is a nucleus Y. It has mass number 20, it has mass number, I would say 30. Tell me, what is the density of nucleus X divided by density of nucleus Y? Density of nucleus is constant, same for this, so it is going to be 1:1. It is going to be 1:1. Absolutely, it is going to be 1:1. Okay, yes. Now, boys and girls, listen carefully. Energy released. This is one more important question from Q value of the reaction. Energy released when two deuterons, 1H2, fuse to form helium nucleus. 1H2 plus 1H2. When 1H2 plus 1H2 join together to form helium nucleus. Helium nucleus means 2He4. And plus some energy is released because it says energy released. You are supposed to find what is the value of this Q. How much energy is released when two deuterons fuse together to form helium. Always remember this Q value of the reaction is binding energy of products minus binding energy of reactants. Binding energy of products minus binding energy of reactants. Now guys, listen carefully. When I say products, product means this. Now see. It says binding energy per nucleon of 2He4 is 7. Means one nucleon, binding energy of one nucleon of 2He4 is 7. How many nucleons are there? 4. Guys, if one nucleon has got 7 binding energy, 4 nucleons will have how much binding energy? You will say, sir, 4 nucleons will have 4 into 7 minus binding energy of reactants. In reactants, you have how many nucleons? 4. This is called reactant, this is product. So binding energy per nucleon of 1H2 is 1.1. One nucleon has got how much binding energy? 1.1. 4 will have how much? 4 into 1.1. Now this is 28 minus 4.4, that is 23.6 MeV. Option C. Option C. Option C. Now take a look at this question, guys. What is the output Y in the following circuit when all the 3 inputs A, B, C are first 0 and then 1? Guys, see, this is called AND gate. This is called a NAND gate. So because when you have this ball in front of AND, it becomes NAND. The job, the work of AND gate is to multiply. So it will multiply. If you send input A and B, it is going to multiply A and B. The job of NAND is whatever goes input over here. So this is C. Whatever goes input in this particular case, it will multiply that A, B into C, then put the bar. This will be the final outcome. So final outcome in this particular case is A, B into C, and then we say bar. Okay. Now if you put all the 3 as zeros first, 0, 0, 0. 0 into 0 into 0 is 0. 0 bar, answer will be 1. It says when you put all the 3 first zeros, answer will be 1. Okay. When A is equal to B is equal to C is equal to 0, Y will be 1. And when A is equal to B is equal to C is equal to 1, answer will be how much? 1 into 1 into 1 is 1. So 1 bar Bar means inverse. Inverse of 1 is 0. So Y will be 0. So what is the correct option? Option D. This is the correct option. This is the correct option, boys and girls. Take a look. Which of the following diode is in the forward bias? See guys, this is what we call PN junction diode. This is P type semiconductor, the P side, and this is N side. This forward side means N, and this is P. This is P, this is N. This is P, this is N. Listen carefully. If P side is connected to higher potential, if P side is connected to higher potential, and N side is connected to lower potential, then diode is in forward bias. Okay, then diode is in forward bias. If P side is connected to higher potential and N side is connected to lower potential, diode is in forward bias. Now see, this P side is connected to 10 volts higher, N side is connected to 5, so this is in the forward bias. So this is 0 volts over here because this is called earthing. So N side is connected to 0, P side is connected to -10, so 0 is greater than -10, so this is reverse bias. Here, P side is connected to -5, N side is connected to -12. So -5 is greater than -12. So this is also in forward bias. This is 0 volt here. So P side is connected to 0, N side is connected to 5. This is again reverse bias. So which one? A and C. A and C only. Okay, very important question. Take a look. An object moves with speed v1, v2 and v3 along the line segment AB, BC and CD. Along the line segment AB, it's moving with speed v1. Along BC, it is moving with speed v2. Along CD, it is moving with speed v3. Okay, v1, v2 and v3. v1, v2 and v3. Where AB is equal to BC. Guys, let's suppose if I say this is X, AB will be equals to BC, this would be X. So my dear NEET aspirants, we say AB will be equals to BC will be equals to X. AB is equal to BC will be equals to X. And then in this particular case, it says AD is equal to 3 times of AB. AD is equal to 3 times of AB. Okay. Now, boys and girls, if AB is equal to 3 times of this, so AD will be equal to 3 times of X. So if this is X, this has to be also X. Yes. Now, if in a question you are given distance and velocity, distance and velocity, distance and velocity, and equal distances, equal. In that case, you directly remember average velocity is. Guys, how many equal distances? 1, 2, and 3. So we'll be writing 3 upon 1 divided by V1 plus 1 divided by V2 plus 1 divided by V3. This is going to be the average velocity in this particular case. Now, if you follow this further, my dear NEET aspirants, it will come out to be the option 4. Okay. Now take a look at this particular question. Take a look at this particular question. See, this is the displacement time graph given over here. You are supposed to tell me in this displacement time graph, okay? So in this displacement time graph, you are supposed to tell me which option is correct. Listen carefully. The average velocity during 0 to 3 seconds is 10 meters per second. This is 0. This is 3. It says average velocity between 0 to 3 seconds is 10. Let's check first. Always remember average velocity is going to be delta x divided by delta t. Change in position with respect to time, or total distance traveled, total displacement traveled upon total time taken. This is going to be final position minus initial position upon final time minus initial time. Now tell me, boys and girls, final position. First tell me final time. It says from 0 to 3. So final time is 3, initial time is 0. Now tell me, at t is equal to 3 seconds, what is going to be the position 5? At t is equal to 0, what is going to be the position 0? So this is going to be 5 minus 0 upon 3 minus 0. So this will be 5 divided by 3. So it says from 0 to 3 velocity is 10, but here it came out to be 5 by 3. So option first is incorrect. Then the average velocity during 3 to 5 seconds. So this is 3 seconds, this is 5 seconds. Now tell me guys, here average velocity. So slope here is 0. So average velocity will be 0. Even you can use the same formula. You can check average velocity. What is that? Final position minus initial position. See, at t is equal to 5 seconds, what is the position? 5. At t is equal to 3 seconds, what is the position? 5. So final position is 5, initial position is 5. Time is 5 minus 3. So this will come out to be 0. So option second is correct. The instantaneous velocity at t is equal to 2 seconds is 5 meter per second. It says instantaneous velocity at this time is 5 meter per second. Okay. Now boys and girls, what I want you to understand in this particular case, at t is equal to 2 seconds it says. Okay. At t is equal to 2 seconds it says. Okay. Now guys, see, whenever there is a straight line, always remember, in case of a straight line, slope at every point is same. If you find the slope at this point, or if you find the velocity at this point, that will be the velocity between this point and this point. Because in case of straight line, velocity, or in case of position time graph, will be same. Straight line means same slope, same velocity. So if I say check for third, velocity at 2 seconds, it means velocity between 2 seconds and 3 seconds. If you find velocity at 2 seconds, that will be same as velocity between 2 to 3. Now tell me, what is the position at t is equal to 3 seconds? 5. What is the position at t is equal to 2 seconds? 0. Okay, so it is going to be final position 5 minus initial position 0 upon. What is the time? 3 minus 2. That is 3 minus 2. That is 1. So it is 5 divided by 1. That is 5 meter per second. That is absolutely correct. This is also correct. Similarly, you can check this one also. This will be incorrect. This is correct. Let me show you E. Average velocity. Average velocity. The average velocity from t is equal to 0 to 9 seconds is 0. What is the position at t is equal to 0? 0. What is the position at t is equal to 9 seconds? That is also 0. So final position 0, initial position 0, divided by time. Time is how much? 9 minus 0. So this is going to be 0 meter per second. So it is 0. This is also correct. Okay. Yes. Now, a projectile is thrown upwards at an angle of 60 degrees. You have basically thrown a projectile upward at an angle of 60 degrees. Okay. The speed of the projectile is 20 meter per second. So this speed is given as 20 meter per second. Okay, no. The speed of the projectile is 20 meter per second. The speed of the projectile is 20 meter per second when its direction is 45 degrees with the horizontal. Let's suppose at this point, its speed is 20 meter per second when it is making the angle of 45 degree with the horizontal. The initial speed of the projectile is, guys, tell me one thing. This is u. Can I say this will be the x component of the velocity, that is u cos of 60? Absolutely, sir. And if this is v, so this will be, v means 20. This will be 20 cos of 45. Absolutely, sir. So basically, initially speed is u. This will be x component. After some time, speed is 20. Angle is 45. So this will be 20 cos 45. We know in case of projectile motion, horizontal velocity remains same at every point. So means this has to be equal to this. So u cos of 60 has to be equal to 20 cos of 45. This has to be equal. Now guys, this will be u cos 60 is 1 by 2 is equal to 20. This cos 45 is 1 divided by root 2. 2 into, so this will be u is equal to 40 divided by root 2. Because if you multiply this over here, now multiply with root 2 and divide with root 2. So this will come out to be root 2 into root 2 is 2. So this will be 40 root 2 divided by 2. 2 ones are 2, 20s are. So this is going to be 20 root 2 meter per second. Okay. Is this clear? Is this clear, boys and girls? An object of mass m is projected from the origin in xy plane at an angle of 45 degrees. Okay. An object is projected from the origin in vertical xy plane at an angle of 45 degrees with the x-axis. So basically you have launched an object at an angle of 45 degrees with the x-axis. Okay, with an initial velocity v naught. This is v naught, this is 45 degrees. Okay, 45 degrees. The magnitude and direction of the angular momentum of the object with respect to the origin when it accelerates, when it reaches the maximum height. It says when the object is at maximum height, its mass is m, its velocity will be this. What will be its angular momentum? Listen to me very carefully. My dear NEET aspirants, if this is V naught, this will be over here V naught cos 45. Cos 45 is 1 by root 2. So this will come out to be V naught divided by root 2. What I want you to understand in this particular case, at topmost point, this projectile will only have horizontal velocity. This horizontal component, that is V naught divided by root 2. Sir, what about the vertical component? Vertical component at topmost point is 0. Vertical component at topmost point will be how much? 0. At topmost point, it has only which component? Horizontal component. Now, my dear NEET aspirants, when it comes to the angular momentum, you say MV are perpendicular. You take that component of radius, which is perpendicular. Now see, radius means you have to find the angular momentum with respect to the origin. This is origin. Join this and this. This is going to be R. Now, if this is R, this will be perpendicular component. This will be parallel component. This is perpendicular component. And my dear NEET aspirants, when it comes to this perpendicular component, this is actually maximum height. This is the maximum height of projectile now because this is at this point. So I can say R perpendicular will be H max. And how do you write H max? That is U square sine square of theta divided by 2g. This is the maximum height of a projectile. So U square, U is the initial velocity. That is how much? That is V naught square. Sine square of theta, theta is 45. Sine 45 is 1 by root 2. So 1 by root 2 whole square divided by 2g. That is 2g. So root 2 whole square means 2. 2 into 2 becomes 4g. So this will be V naught square divided by 4g. Now, can you tell me what is going to be the angular momentum? L will be m. Instead of velocity, this will be V naught divided by root 2. Okay. Then R perpendicular. R perpendicular is how much? That is V naught square divided by 4g. So angular momentum will be m V naught cube divided by 4 root 2, I would say g. Okay, 4 root 2, I would say g. Okay. Okay. So mv naught cube into 4 root 2g. Now you have got two options along positive z direction, along negative z direction. Now guys, whenever you say angular momentum is actually this. L is equal to R cross mv, R cross mv. Okay, or m into R cross v. Now R cross v, what is the direction of R cross v? Listen to me very carefully. This is the radius. In this particular case, you can extend this radius over here. Now guys, this is R, this is V. Curl your fingers from R to V, that will be along negative Z axis. So you can say negative Z. Okay, now take a look at this question. Take a look at this question. First, take a look at this question. A force on a rocket moving in a force-free space with an exhaust velocity of the gas is 300 meter per second. There is a rocket. Okay. Okay. And this rocket, inside this rocket, there is a gas fuel which is burning and it is sending that gas out. It is sending that gas out. Okay. Now, velocity of the gas, this velocity of the gas, it is 300 meter per second. Okay. Now, my dear NEET aspirants, you might have heard, I have told you previously, when the fuel of the rocket burns, it sends the gas out. So in return, this gas pushes the rocket up. So it creates the upthrust force. So basically, this upthrust only takes the rocket up. And this upthrust, this is equal to V dm by dt. dm by dt means with what rate the fuel is burning, with what rate the mass is decreasing over here. Because when fuel burns, mass decreases. So upthrust force is given as 210 Newton is equal to velocity of the exhaust gas, which with what velocity exhaust gas is coming out, that is 300, and this will be dm by dt. Okay, so dm divided by dt will come out to be 210 divided by 300. It will be 0.7 kg per second. Okay, this is the value of dm by dt because we were supposed to find the rate of the combustion of the fuel. So that means dm by dt. This is rate of the combustion of the fuel. Take a look at this. Now see, guys, tell me, what is the answer to this particular question? Smash the like button if you're not liked the session yet. Come on. Now see, the impulse is large in the following figure. The impulse is large in the figure. This, and this. Now see, whenever you say impulse, impulse means change in momentum. Impulse means change in momentum. And boys and girls, when we talk about change in momentum, or you can write it like this, that is integration of f dt, or you can say area under force time graph. So either you say this impulse is change in momentum, or you say integration f dt, or you say area under force time graph. It's one and the same thing. Now these are all the force time graphs. Now you have to tell me impulse is large in which case. Now if you check the option second, You see, area under force time graph is large. Area is large. If area is large, that means impulse is large. Impulse is large. If area is large, that means impulse is large. Okay? If area is large, that means impulse is large. Whenever you see the combination of the blocks, something like this, first you have to find the acceleration of this system. Acceleration will be always net pulling force upon net mass. Net pulling force upon net mass. Now, my dear NEET aspirants, you see, this would be over here 5G. This would be over here 3G. See, on this block in the downward direction, what is the force acting? That is 5G. On this block in the downward direction, that is 3G. So when it comes to the acceleration, my dear NEET aspirants, that will be net pulling force, this force minus this force, that is going to be 5G minus, I would say, 3G. Divided by net mass would be this plus this plus this. Sir, shall we consider tension in the pulling force? No. So 5 plus 2 plus 3, 5 plus 3 is 8, 8 plus 2 is 10. So this would be 10. So this will be 2G divided by 10. So G is also 10. This and this will cancel. So acceleration will be 2 meter per second square. So first you will be finding the acceleration of the system. Now, my dear NEET aspirants, if I say you find the tension, consider this block if you want to find T1. Okay. So we say consider this block. This is 5 kg. In the downward direction, what is the force acting? 5G. In the upward direction, what is the force acting? Tension T1. Now guys, since this 5G is greater than 3G, so I can say this is going to be the acceleration of the system. So this is going to be the acceleration because this is greater than that. So this is the direction of acceleration. So if this is the direction of acceleration, means this net force will be in the downward direction. Means this force is greater than this force. So apply Newton's second law. What does that say? This minus this. So 5G minus T1 will be equals to mass into acceleration, m into a. So this is going to be 5G is 50 minus T1 will be equals to mass into acceleration. Mass over here is 5 and acceleration of the system is 2. So this is going to be 50 minus 5 2s are is how much? 10. This will be equals to T1. So T1 will be, my dear NEET aspirants, T1 will be, my dear NEET aspirants, 50 minus 10, that is 40. 50 minus 10, that is 40. Similarly, if you want to calculate this one, This block. On this block in the downward direction, what is the force acting? That is 3G. What is the force acting in the upward direction? That is 2T2. And my dear NEET aspirants, this is over here. This is over here. I would say acceleration of the system. So this will be the acceleration. So can I say in this particular case, upward force minus downward force? So this is going to be T2 minus 3G is equal to mass into acceleration. So this is T2 minus 3G, my dear NEET aspirants. T2 minus 3G. So T2 minus 3G. So 3G means 30. Mass into acceleration, boys and girls. Mass is how much? That is 3 into, I would say, 2 is 6. So T2 will come out to be 36 Newton. So this is the way by which you can solve these particular questions. First, find the acceleration, that is net pulling force by net mass. Then once you get the acceleration, then consider the blocks. You can find the tension in the individual blocks. I hope this is also crystal and clear. One more important thing, question from the, this is also very important, from the portion that is work, power and energy. Now guys, see, an object of mass 1000 grams, 1000 grams means 1 kg, experiences a time dependent force. Okay, force acting on this object is this. The power generated by the force at time t is, guys, listen to me very carefully. If this is the force, when it comes to the power, you say power is dot product of force and velocity. Force you know, but velocity you don't know. So let's find the velocity over here. So my dear NEET aspirants, we say velocity. Okay, before this force, let's find acceleration. Acceleration will be force divided by mass. Okay. Now tell me, what is the value of force? So that is 2T into I cap plus 3T square J cap divided by mass. Mass is 1. Now, boys and girls, what I can say in this particular case, this acceleration is going to be 2T I cap. Listen to me very carefully. This is acceleration, that is 2T I cap plus 3T square J cap. Now, if you get the value of acceleration, now you can find the change in velocity. Now see, delta V will be integration of A dt. Delta V will be integration of A dt. We know this. If you know the acceleration, you can find change in velocity. So delta V will be integration of acceleration. Acceleration is 2T I cap plus 3T square, I would say J cap into dt. Okay, now delta V, find the change in velocity. What is the integration of 2T square? It is going to be 2T square divided by 2T into I cap plus, what is the integration of 3T square? It is going to be 3T cube divided by 3 into J cap. 3 will cancel, 2 will cancel. So what I can write over here, change in velocity came out to be, that is T square I cap plus T cube J cap. Okay. Now, boys and girls, what you can say over here? Final velocity minus initial velocity. Since it says that this object experiences time dependent force. So means this object moves because of this time dependent force. So we say when time is 0, what will be the force? 0. So in this case, we will be assuming, here we have to assume initial velocity will be 0. So we can say final minus initial. So final velocity will be, that is T square into I cap plus T cube into J cap, something like this. Now, boys and girls, when I can see, what I can see over here, power will be F dot V. Now this is force. This is force. And this is velocity. Now, how do you do the dot product? Let me write the force over here. 2T I cap plus 3T square J cap. Now do the dot product. How do you do the dot product, my dear NEET aspirants? You say coefficient of this multiplied by coefficient of this. That is going to be T square into, I would say, 2T. Plus coefficient of this into coefficient of this. T cube into 3T square. Now this power is equal to, this is T square into T. So this is going to be 2T cube plus T cube into T square. This is going to be 3T raised power 5. So I can say option C is the correct option in this case. Guys, tell me, is this clear? Is this clear? Tell me, guys, is this clear? Okay. Let's move on to this particular question. One more important question. Take a look, guys. Take a look, guys. A body of mass 2 kg is moving along x direction such that its displacement as a function of time is given as this. So displacement as a function of time, x of t, it is alpha t square plus beta t plus gamma, where alpha and beta are given. The work done on the body during the time interval t is equal to 2 seconds to 3 seconds is. Listen, guys. We will be using the work energy theorem in this particular case. What does that say? Work energy theorem says W is equal to change in kinetic energy. Work done is equal to change in kinetic energy. So this is going to be final kinetic energy minus initial kinetic energy. This is going to be something like this: 1 by 2m final velocity square minus initial velocity square. Something like this. Now, my dear NEET aspirants, what I want you to understand in this particular case, this is position. When I say velocity, velocity will be dx by dt, differentiation of position with respect to time. Now tell me, what is the differentiation of this? This is going to be 2 alpha t plus, I would say, beta over here. Now, boys and girls, listen. You need to put alpha over here 1, beta over here 1. So velocity will come out to be 2. Alpha is 1 into t plus beta is also 1. So this velocity will come out to be 2 plus 2t plus 1. So what I'm trying to say in this particular case, my dear NEET aspirants, what I'm trying to say, now could you please tell me what is the velocity at t is equal to 2 seconds and velocity at t is equal to 3 seconds? So I would say at t is equal to 2 seconds, what is going to be the initial velocity? Put t is equal to over here. 2 into 2 is 4 plus 1 is 5 meter per second. Okay, at t is equal to 5 seconds, if you put t is equal to 5 seconds over here, okay, t is equal to 5, 2 into 5 is, okay, t is equal to 3, t is equal to 3 seconds. Put t is equal to 3 over here, final velocity will be 2 into 3 is 6 plus 1 is 7 meter per second. Now, you can say this work done is going to be 1 divided by 2m. Mass of the object is given as 2 kg. If you check over here, final velocity square, final velocity is 7 square minus initial velocity is 5 square. So work done is going to be this and this will cancel. So this will be 49 minus 25. This is going to be 24 joules. So 24 joules is the correct option in this case. Okay. Yes. Let's take a look at this particular question. Let's take a look at this particular question. See, guys. What does the question say? A mass m moves in a Now guys, a mass m moves in a circle on a smooth horizontal plane with a velocity v naught at radius r naught. With a velocity v naught at radius r naught. The mass is attached to a string which passes through a smooth hole as shown. So basically there is a mass over here, my dear NEET aspirants. Its velocity is how much? V naught. Okay. And it is attached to a rope. It is attached to a string. And that string is basically passing through the hole shown in the figure, something like this. Consider this as a table over here. This is some sort of table, I can say. It's placed on the table. Now, my dear NEET aspirants, what does it say? The tension in the string is increased and the mass is moved to r naught divided by 2 radius. So basically, if you pull the string over here, so this mass is going to come closer to the center point. What does it mean? What does this statement mean? The tension in the string is increased. The tension in the string is increased means you're pulling the string. If you pull the string, you are going to bring this mass at r naught divided by 2. Okay. And if this happens, then the final value of the kinetic energy will be. Could you please tell me what is the initial value of kinetic energy? Initially, I would say kinetic energy of this object is 1 divided by 2 mv square. Mass is m, velocity over here is v naught, so v naught square. This is initial kinetic energy. Now guys, final kinetic energy will be, first you need to calculate when you bring this mass at r by 2 distance, what is going to be the final velocity? Okay, what is going to be the final velocity? Now my dear NEET aspirants, listen to me very carefully. If I say, in this particular case, how do we find the final velocity? Conserve the momentum. We say initial angular momentum. Angular momentum initially will be equals to angular momentum finally. Okay. Angular momentum initially will be equals to the angular momentum finally. Now, initially angular momentum at this particular point is, listen to me very carefully. If the object is moving at r naught radius with v naught velocity, what will be the angular momentum? mvr, mv naught into r naught. mvr perpendicular na? Yes. So finally, my dear NEET aspirants, if you bring this mass to this distance, r naught by 2, you can say final mass is m, final velocity is v dash. That is what we are supposed to find out. And it is going to be r naught divided by 2. r naught, and then you have m will cancel. So this v dash will be, I would say, 2 times of v naught. Now tell me, you got with the help of conservation of angular momentum, because angular momentum will be conserved over here. There is no net external torque acting. So now tell me, in this particular case, what will be the final kinetic energy? Final kinetic energy will be 1 by 2 m v dash square, final velocity square. So kinetic energy finally will be 1 by 2 m. Okay, m is basically m naught. And then what is the value of v dash? 2 v naught whole square. So this is going to be 1 divided by 2m. So 2 square is 4 and this is v naught square. So 2 ones are 2 twos are 4. So this is going to be 2 m naught into v naught square. This is going to be kinetic energy final. Okay. Okay. So I believe this is crystalline clear. Guys, tell me in the chats if this is crystalline clear. Okay. Okay, let's take a look at this particular question, guys. See, a particle of mass 5 kg is moving with a uniform speed v is equal to 3 root 2. V is equal to 3 root 2 in x or y plane. Along the line y is equal to x plus 4. Guys, see, an object is basically moving along this line. Y is equal to x plus 4. Can you please compare it with, I would say compare with y is equal to mx plus c. Compare it with y is equal to mx plus c. Now, guys, in this particular case, what I want you to understand over here is when you compare it with y is equal to mx plus c, here it is y, here it is y, here it is x, x, c, c. So I can clearly say in this particular case, value of slope m is 1. Slope is 1. Slope means tan theta. Tan theta is 1. When is the value of tan theta 1? When theta is 45 degrees. If you keep theta 45 degrees, so I would say slope would be 1. And value of c in this particular case is 4. The c is 4. Now, if you draw this on the graph, let me make it on the, let me show you on the graph. Okay. So this is y-axis. This is x-axis. Now, boys and girls, what I want you to understand in this particular case is, this is a straight line. You have to draw the straight line in such a way so that its angle with the horizontal should be 45 degrees. And this intercept must be 4. So it has to be something like this. So this intercept, this is the origin. From here to here, I would say c is equal to 4. And this theta is equal to 45 degrees. Okay. And slope has to be positive. Slope of this is positive, basically. Now, boys and girls, you have to tell me in this particular case, the magnitude of angular momentum of the particle about the origin. Magnitude of angular momentum of the particle with respect to the origin. See, guys. And this object, it is actually moving with a speed. How much? 3 root 2. Now, guys, tell me one thing. If this speed is 3 root 2, could you please tell me, and this angle is 45 degrees, because this is 45, this is 45. This component will be how much? 3 root 2 cos of 45. Cos 45 is 1 by root 2. So I can say this will be over here 3 under root 2. Cos 45 is 1 divided by root 2. Root 2 will be cancelled. So this is 3. Now, guys, tell me one thing. This is origin from here to here. This you can consider as R. Because if you have to find the angular momentum of this object with respect to the origin, you can say L is equal to mvr, perpendicular. So L will be, what is the mass of this object, by the way? What is the mass of this object? Mass of this object is given as 5. Velocity. Which component of the velocity you are going to take? You will take that component of the velocity which is perpendicular to R. So that means this is 3. And R, this R over here is as 4. So L will be 5 into 3 is 15. 15 into 4 is 60. So angular momentum in this particular case is 60. I believe this is crystalline clear. I believe this is crystalline clear. Tell me, guys. Take a look at this question. Take a look at this question. Take a look at this question. See the question, guys. A proton and an alpha particle. A proton and an alpha particle are accelerated through same potential difference in the region of uniform electric field. Guys, see. This is the region of uniform electric field. You have sent a proton. Okay. You have sent a proton. This is the proton in this electric field and magnetic field, and you have sent an alpha particle. Whenever the charged particle enters the magnetic field perpendicularly, it follows the circular path. That will have radius, call it radius of proton. That will have radius, call the radius of alpha particle. Okay. Then it says compare the radius of the circular path followed by them. Means you have to say radius of proton divided by radius of alpha particle. This ratio you guys are supposed to find out. Now tell me. Directly remember, whenever charge moves into the magnetic field, a radius will be like this, under root of 2m Q delta V divided by QB. Okay. 2mq delta V divided by QB. This is the radius of the charged particle. This is the radius of the charged particle when it moves inside the magnetic field. This is the radius of the charged particle when it moves inside the magnetic field. Okay. Yes. Now, boys and girls, listen to me very carefully. In this particular case, when it comes to the proton and when it comes to the alpha particle, proton has got charge E, alpha particle has got charge 2e. Proton has got mass m, alpha particle has got mass 4m. Okay, m and 4m, E and 2e. Now, boys and girls, do one thing. Can I say over here this radius will be proportional to? See, both proton and alpha particle are accelerated through same potential difference. So delta V is same. Okay, we say delta V is same. And they are entering the same magnetic field B. So magnetic field is also same. So the quantities which are constant in an equation, you can remove those quantities, my dear NEET aspirants. So you can say R will be proportional to, I can say under root of m into q divided by this q. Okay, divided by this q. Now let's make it a bit simple. Rationalize this, multiply with root q and divide with root q. So root q into root q is q. So this q will be cancelled with this q. R will be proportional to under root of m divided by q. M divided by q. Now, boys and girls, you tell me a radius of proton divided by radius of alpha particle. Now tell me under root of mass of proton. What is mass of proton? Okay, mass of proton is m, charge is E divided by under root of what is mass of alpha particle, that is 4m, charge is 2e. You can write it like this, under root of m divided by E into under root of 2e divided by 4m. m e e. So root 4 is 2. So it is a root 2 divided by 2. Now multiply, rationalize root 2 with root 2. Root 2 into root 2 is 2 with cancel with this 2. So 1 divided by root 2 is the answer in this particular case. So answer in this particular case is 1 divided by root 2. Is this clear? Okay. Is this clear, boys and girls? Okay, now see. There's a question over here. Find the direction of the current. Find the direction of the current in the coil with respect to the observer. Okay, this is the observer. Guys, see. In this particular case, this is a magnet which is moving away from the coil. This is the magnet which is moving towards the coil B. So I can say whenever the magnet moves away from the coil, flux through the coil changes. Whenever flux through the coil changes, current is produced. Whenever the magnet moves close to the coil, so flux through the coil increases, so current is produced. We have to find the direction of current. Now see, if the coil moves away from the magnet, guys, directly remember, in this coil, an imaginary bar magnet is created. So it will create north from this side, south from this side. Because this coil will try to attract. So this create an imaginary bar magnet. That imaginary bar magnet tries to attract this particular magnet, which is moving away. So that's why it is creating north pole, here it is south pole, because north attracts south, unlike poles attract. And if this magnet is moving towards this coil, it will create an imaginary bar magnet, north from this side, south from this side. Why? Because north will repel north. Like poles repel and unlike poles attract. Like poles repel and unlike poles attract. So if, guys, listen carefully. So if the magnet moves away from the coil, this creates an imaginary bar magnet which will try to attract this magnet. If the magnet moves close to the coil, this creates an imaginary bar magnet which repels this magnet. Now see, If the observer sees south pole in the imaginary bar magnet, listen carefully, then current will be clockwise. These are the sign conventions you have to remember. See, this observer is facing south pole of imaginary bar magnet. So current in this coil is clockwise. This observer is facing north pole. This observer is facing what? North pole of this bar magnet. So in this particular case, current will be anti-clockwise. So if observer faces north pole in the imaginary bar magnet, current is anti-clockwise. Otherwise, current is clockwise. Okay. Now see, this is also the question which was asked in J Mains 2021. So this is the question which I feel is very important. You have got multiple dielectrics. These are the plates of the capacitor in which you have got multiple dielectrics placed in series. C1, C2, C3. And dielectric constant of this is K1, this is 3K, this is 5K. Width of this is D, 2D, 3D. You have to tell me what is the capacitance. Guys, whenever dielectrics are placed in series, the capacitance of the capacitor becomes epsilon naught A upon D1 by K1. A is the area of the capacitor plates plus D2 by K2 plus D3 by K3. You will be saying C is equal to epsilon naught A. Epsilon naught A upon D1 by K1. D1 is D, K1 is K plus D2 by K2. That is 2D divided by 3K plus 3D by 5K. 3D divided by 5K. So C will be epsilon naught A upon. Now take this D divided by K out. It will be 1 plus 2 divided by 3 plus 3 divided by 5. So my dear NEET aspirants, if you solve this, so it will be epsilon naught A upon. This will be D divided by K. Now, what is the solution of this? If you solve this, my dear NEET aspirants, this will be 34 divided by 15. Now take this in the numerator. This will be 15K epsilon naught A divided by 34D. Option A. So basically you have to remember this particular formula and you will get the answer of every single question. So many times questions have been asked on this one. Now see, find the resistance of the concentric cylinders in the given figure. Now see, this figure is something like this. This is a cylinder basically, something like this. This is a cylinder. Now, my dear NEET aspirants, in this particular case, this cylinder is filled from this side. It is filled from this side. Yes, this cylinder is filled from this side. Take a look. Take a look. It is hollow. This portion is hollow. And radius of this portion is, I would say, R. And radius of this portion is, I would say, 3R. So current is flowing from this portion only. So if current is flowing from this portion only, so this portion only is going to create the resistance. This portion. There will be no resistance from this. Now, in the question it says you have to find the resistance. So this portion only is going to create the resistance. This is hollow from inner side. So if I say resistance in this particular case, you say rho L divided by A. Now, which portion of the area is going to create the resistance? Only this shaded portion. So you can say this area will be, guys, what is the total area? Pi r square. So pi into r. What is the total radius? That is 3r whole square. Okay. Then minus. What is this area? Guys, if you say total area minus this area, you will get this area. So that is going to be pi r square. Pi r square. This is capital R. So pi r square. So area will come out to be, that is 9 pi r square minus pi r square. So 9 pi r square minus pi r square, area will come out to be 8 pi r square. Okay. So this is the area of the cylinder which is going to create the resistance. So this area. So when I say a resistance, R is equal to rho L. Length is L divided by area, that is 8 pi r square. This much is going to be the resistance in this particular case. Take a look. Find the equivalent resistance over here. You have to tell me equivalent resistance. Guys, see, this resistor, and this resistor, these three are in parallel. So R equivalent in this particular case will be, when the resistors are in parallel, their equivalent will be R by 3. So that is going to be 30 divided by 3. So this will come out to be 10. Their equivalent is 10. Okay. Now guys, listen. Potential of this point is Y. Even potential of this point is also Y. Potential of this point is Y. Same goes here. Potential of this point is Y. Potential of this point is Y. Okay, potential of this point is Y. Now, if the potential across both the ends is same, so means this is going to short circuit. This is going to short circuit. Now, potential of this is Y, here also Y. Here also Y. Now, same wire goes till here, here also Y. So, this also will be short circuit. Okay. Now, guys, let's redraw. Redraw. This is point X. This is point X. Now, resultant of this and this will be 10 ohms. Then this 20 is attached over here. And this side is basically Y. Then, my dear NEET aspirants, from this side you have got 10 and this 20. This. Okay, so this is joined because this also is potential Y. This is 10 and this is 20. Now, what is the resultant of these two? This is 30. What is the resultant of these two? This is 30. So finally, what I can say over here, this is 30. This is 30. This is X and this is Y. So this is 30, this is 30. If two resistors are in parallel and both are identical, R equivalent will be simply R 30 by 2. R by 2 na? So this is going to be, I would say, 15 ohm resistance over here. Net equivalent of this came out to be 15. Let's take a look at this question. In the following circuit, this is the question given over here. In the following circuit, a meter bridge is shown in its balanced state. Meter bridge means which measures the unknown resistance. This is one resistance, another resistance. This is a meter wire. This is the balanced state. Balanced state means that state when current through the galvanometer becomes 0. No current flows through the galvanometer. The meter bridge wire has a resistance 1 ohm centimeter. Calculate the value of unknown resistance X and current drawn from the battery of negligible internal resistance. Guys, see, this is a meter bridge. It says first find the value of this unknown resistance X. Then find the current in the circuit. Listen carefully. If this is in the balanced state, so what is the balancing length over here? That is 40 centimeters. This would be 60 because total is 100 centimeters. Now, how do we find? See, how do we find? We say this resistance P divided by this resistance Q will be equals to this balanced state L divided by this 100 minus L. So, P is X, Q is 6 is equal to L is 40, 100 minus L, that is 60. This will cancel, this will cancel, X will come out to be 4 ohms. This resistance is 4. Now, my dear NEET aspirants, listen carefully. It says that the meter bridge wire has a resistance of 1 ohm centimeter. Now, it says resistance of this is 1 ohm centimeter. This is how many centimeters? 40. So, this will have got how much resistance? Per centimeter is 1 ohm. So, 40 centimeter will have how much resistance? So, this will be 40 ohms. This much will have how much resistance? That will be 60 ohms. I can say 60 ohms. Okay. So basically it is 40 ohms and 60 ohms. Now tell me, you have to find the resistance in this circuit. Now you can make it like this. This is over here, x, value of x is 4. This is 6. This is 40 ohms. This is 60 ohms. Now, boys and girls, listen to me very carefully. 6 plus 4 is 10. Equivalent of this is 10 ohms. This is 100. Okay. If I say R equivalent in this particular case, R equivalent, could you please tell me what is the R equivalent? That is this resist. See, that will be R1, R2. When you have two resistors in parallel, their equivalent resistance is R1, R2 upon R1 plus R2. So you can say R equivalent in this particular case, R1, R2. R1 is 10 into, I would say, 100 divided by R1 plus R2, that is 110. 0, 0 will cancel. This will be 100 divided by 11. This came out to be equivalent resistance. Okay, now what is the value of this battery? Battery is 6 volts. Now you have to find the current. Current is V by R. V divided by R equivalent. So current in this particular case is V. V is 6 divided by R equivalent. R equivalent is 100 divided by 11. Take this over here. So this is going to be 66 divided by this one. Is this clear? Is this clear, boys and girls? Is this clear? Okay, one question is there. This I would want you guys to do from your end. See, I'll give you the hint over here. And di by dt in this particular case, di divided by dt over here is minus 0.5 ampere per second. See guys, you have to tell me in this particular case, find VA, potential of point A. Find the potential of point A. This is what you guys are supposed to find out. Guys, smash the like button if you're not liked the session yet. Now take a look. See? You have to tell me the potential of this point. Guys, see. Always remember, first do one thing. Find the potential in each, I would say, load. Here potential is 5 volt. Here, how do we find the potential in capacitor? V is equal to Q divided by C. Q is how much? 2 microcoulomb. C is how much? 10 microfarad. So that is going to be 1 by 5 volts. Done this one. Let's find the potential here. In case of inductor, we find potential V is equal to L di by dt. Okay. So we can say V is equal to L. Value of L. L in this particular case is 50. Di by dt is 0.5. 0.5 means 5 divided by 10. This and this will cancel. So this will be 25 volts. Ignore this negative sign. This is decreasing. So otherwise it is minus L di by dt. Still it will be positive. Here, in case of resistance, we say potential is I into R. V is equal to I. I is, what is the current flowing? That is 2 amperes. R in this particular case is 4. 2 into 4 is 8 volts. Okay. First you find the potential in every load over here. Like here you can say V is equal to Q by C. Here V is equal to L di by dt. Here V is equal to IR. Now listen to me very carefully. This is the positive potential. This is the negative, because this is positive plate, negative plate. Now see. In this particular case, this is the direction. Guys, listen to me very carefully. This is the direction of current. This primary current. Okay. And it says this current is decreasing. Di by dt means change in current. If it is given as negative, means current is decreasing. Always remember. If through the inductor, current is decreasing, primary current is decreasing. this inductor will support the primary current. Okay. Lenz's law says that if the primary magnetic field is decreasing, support the primary magnetic field. If the primary current is decreasing, support the primary current. Support the primary current means this is primary current, and which is how much? 2 ampere. It is decreasing because we got to know from this negative side. It will send one more current like this. This is I secondary in the same direction. Why is the same direction? Because this was decreasing. If the current was increasing, then it would have sent the current in the opposite direction. Now, this is the direction of the secondary current. Now, guys, listen carefully. And one more important thing. This is the direction of current. So this will be positive, this will be negative, because current always flow from positive to negative. Now see here. Sir, if this is the direction of secondary current, this is only possible if you keep positive potential terminal from this side and negative terminal from this side. This will be positive, this will be negative. Why? Because current will always come out of positive. So I secondary will have this direction only if this is positive terminal. Now see, redraw. This VA, then this battery over here. It has got potential 5 volts. Then this battery over here. This is positive, this is negative. So positive, negative. This has got potential 1 by 5 volts. Then this battery over here, boys and girls, this one. This is positive, this is negative. This has got how much potential? 25 volts. Then this is negative, that is positive. This is negative, this is positive. This has got potential how much? That is 8 volts. And this is over here 0 volts because B has got potential 0. This is VA. So basically, whenever you have a question of this sort, you make the first find the potential in every case. Then make the batteries positive, negative, positive, negative. What is the logic here? Positive plate, negative plate. What is the logic here? Current flows from positive to negative. If this is the direction of current, so this will be positive, this will be negative. What is the logic here? Logic here is if the direct current is decreasing, so you support the primary current with the secondary current in the same direction. Now that is only possible if you keep positive from this side, negative from this side. Now move from A to B, select the path from A to B. So first you will be writing VA, then go from higher to lower. So this will be minus 5 volts. So whenever you move, if this is your path, A to B, so you are moving from higher potential to lower potential. Its potential drop is taken as negative, minus. This, you are moving from higher to lower, 1 by 5 volts. Minus, you are moving from higher to lower, 25 volts. You are moving from lower to higher, this will be plus 8 volts is equal to 0. Now solve this and check how much it is coming. I believe this is crystalline clear, boys and girls. Okay, I believe this is crystalline clear. With this, we are done with this particular session. Okay, all the 45 questions. Thank you so much, boys and girls. Okay. Chalo guys, take care. Huh? See you. Thank you so much. Okay. Chalo, take care and bye-bye.